Hello students, and welcome to the beginning of a very exciting lesson. My name is Mr. Monster, and I will be your guide for this lesson. Anytime you see me, focus on the information I'm giving you because it will be helpful material that you'll need to know. You can call your upcoming activity Recipe, How to Boil Water. To begin with, you will see a series of pictures, and as you view them, begin to formulate what they have in common. Ready? 1, 2, 3, go. Thoughts? You probably need to see them again, so let me slow them down a bit. Did you get them all? Why don't you discuss amongst yourself for a moment? Alright, let's see those pictures a third time. This time with a hint. Any thoughts? We may be getting closer to the answer that I think you are formulating. Let's see them one more time. Any last thoughts? Could water be the common theme in all of these pictures? Well, yeah, it is. In this lesson, we will be examining the properties of water and how it can appear differently depending on a couple of variables. Specifically, we will be studying how liquid water can transform into steam. Let's first look closely at the bottle of water you brought to class today, though. If you could zoom in very closely with a powerful microscope, you would see something like this. Each of the red and white spheres represents a very tiny particle called an atom. Can anybody recall another name for water? Maybe what a chemistry teacher would call water? That's right, H2O. And as you can see, there are 2 hydrogen molecules and 1 oxygen molecule that makes up 1 water molecule. Now, in order for the liquid in your bottle to appear the way it does, millions and billions of water molecules have to be linked together by very weak bonds called hydrogen bonds. How these bonds are arranged, however, influences exactly how your water appears in the pictures we saw earlier. What we are talking about here is a phase change. There are actually 4 phases of matter. I am sure that solids, liquids, and gases are on the tip of your tongue since you learned this last year. As it turns out, though, there is a 4th state of matter called plasma. You may learn about plasma when you get into high school, but for now, how about we refer to solids, liquids, and gases as SLG? I think that sounds a lot simpler, and as a matter of fact, it might be even easier to remember if we say that SLG, solids, liquids, and gases, stands for Slimy Lizard Jim. This week we will be studying the phase change between liquid water and gaseous water. If you want to look at it this way, a liquid takes the shape of its container, and a gas fills the entire shape of its container. There are 2 important vocabulary terms we need to get out of the way, though. Vaporization and condensation. Vaporization is when a liquid turns into a gas. Another word for a gas is a vapor. Should be easy to remember now, shouldn't it? Condensation, on the other hand, is when a gas turns into a liquid. Focus on the word condensation again. Any word you can pick out? That's right, condense. And what does that word mean, condense? To make smaller. Correctamundo. A gas is big and a liquid is smaller in overall size, so it makes sense to use the word condensation to describe a gas turning into a liquid. From now on, I want you all to use these terms as we begin this week-long activity. We can go about making water change from a liquid to a gas and a gas to a liquid in a couple of ways. What is the most familiar way? Well, that's right. Adding a certain amount of heat to liquid water will turn it into, that's right, a gas. We'll figure out how much heat that is this week, so stay tuned. Now, in the case of water, we are talking about steam. What you may not realize, though, is that you can achieve the same exact phase change without adding heat. What could that be? Well, as it turns out, if you could somehow remove the air surrounding liquid water, it will boil without having any heat added to it. Let's look at an example. Here we go. Well, it looks like a whole lot of nothing is happening because you can't see the air actually being sucked out of the chamber. Now, once nearly all the air is sucked out, there is no longer any pressure pressing down on the hydrogen bonds. They are free to break up, and if that happens, the water molecules are going to separate, and everybody with me, they'll turn into a gas. As you can see, that's exactly what happened. We are seeing water boiling without any added heat. All we have done here is remove the air pressure, and you can see the results. You all will have a chance to experiment with this during this week. Completing a phase change can be a little more complicated though. What if we add something to the water before we heat it up or remove the air? What if we add something like salt? We will all find this out this week. Tomorrow, you will be divided into groups and we will go into the lab. We will be measuring things like temperature and the time required to achieve a phase change. We will even graph your results to see if we can't find any trends. You will have to follow instructions very carefully and recall concepts that we learn every day in order to do well on Friday, which is the last day. I hope you enjoyed this lesson. This is Mr. Monster signing off. We'll see you tomorrow.